Hello. So, I was perplexed by a question in Persona 4 Golden yesterday. Um, I have a degree in mathematics, a bachelor's degree, um, and they provided a question about what numbers were real, talking about the set of whole numbers. So I expect to see numbers. Instead, we received a list of sociable numbers, amicable numbers, um, marriage numbers, and what was the other? What was the other here? Betrothed numbers. And I was confused. I was surprised because I had never seen that before. Um, Maybe in passing, but I was shocked. I had no idea. Um, I eventually ruled the answer down to the correct one. Marriage numbers were not real, just based on the kind of word. Um, but yeah, so I wanted to make a video going over what these numbers are, both for myself and for other people. Starting with sociable number. So, in mathematics, sociable numbers are numbers whose aliquot sums form a periodic sequence. It's been a long time since I've been in college, but okay. They are generalizations of the concepts of perfect numbers and amicable numbers. Oh, so maybe we should start with amicable. The first two sociable consequences are sociable chains, were discovered and named by the Belgian mathematician Paul Paulet in 1918. Sociable sequence, each number is the sum of proper divisors of the preceding number, i.e., the sum excludes the preceding number itself. For the sequence to be sociable, the sequence must be cyclic and return to its starting point. Okay. Also, all of these screenshots I'm sharing here are from Wikipedia. So if you're interested and want to learn more or look at the actual sources, please do. Um, I'm not gonna super deep dive into this. I don't know why people would write false information about math concepts. All right. So let's look at an example. Some of the proper divisors of 1,264,460 are 2 squared times 5 times 17 times 3,719. Gotta be honest. This is a little beyond where my mathematical headspace is nowadays. Like I said, it's been a while since I've been in college. What, 10 years? Period of the sentence or order of the set of sociable numbers is the numbers in this cycle. If the period of the sequence is 1, the number is a sociable number of order 1, or perfect number. Um, Okay. So the example, this has a period of 4 as the period the multipliers here. 1, 2, 4, 5, 10, 17, 20. Hmm. A lot of these are just doubling, but some are not. What? It goes on to give known sociable numbers. Let's gonna quickly review perfect number. A perfect number is a positive integer that's equal to the sum of its positive divisors. Okay. So 6 is perfect because 1, 2, and 3 are its divisors. You can divide 6 evenly by those. And if you add 1, 2, and 3 together, you get 6. So it's a perfect number. Uh, 4 is not perfect, for example, because 1 and 2 are its divisors, and 1 plus 2 is 3. Okay. So, it's not super duper helpful for having me, helping me understand sociable numbers. Bum, bum, bum. In number theory, the aliquot sum, positive integer, is the sum of all proper divisors. Form a periodic sequence. A periodic sequence is a sequence for which the same terms are repeated over and over again. I don't... Missing something here. Purely periodic sequence with period P or P periodic sequence is a sequence A1, A2, A3 satisfying A n plus P equals AN. So it says this boyo has a period of 4. How does that create this string? Hmm. I'm not sure. All right. Well, sociable numbers are a thing. I'm a little at a loss still as to what they are and how I would find them. According to Wikipedia, there are 9 known sociable numbers. No. Yes. As of July 18th. So, wonder what they're used for. It's conjectured that the number of sociable number cycles with length greater than 2 approaches infinity. Sure. Okay. Well, that's sociable numbers. There we go. Now we know, right? Perfect. All right. Let's look at amicable numbers. Hopefully these are a little easier. Amicable numbers are two different natural numbers related in such a way that the sum of the proper divisors of each is equal to the number. That is to say, SA equals B and SB equals A. The smallest pair of amicable numbers is 220 and 284. So sum of the proper divisors of A equals B, and sum of the proper divisors of B equals A. Is that what I'm understanding here? Small, yeah. They're amicable because the proper divisors of 220 are 1, 2, 4, 5, 10, 11, 20, 22, 44, 55, and 110. And if you add all those together, it's 284. Proper divisors of 284 are yada 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 yada. You add all those together, the sum is 220. Neat. Okay. That's really interesting. I'd never considered numbers might have this property. Just from a logical point, you might say, yeah, um, all the divisors of 220 is, of course, less than 284. But once you actually like list them out, you can see that goes well beyond 220. A little bit surprising. First 10 amicable pairs. What that probably means is the more numbers that are divisible by lower numbers, right, have a higher total. Because if you consider, like, 220 divided by 2 is 110, right? That's the highest divisor you can get, 110. So ideally, you'd want also the second possible highest divisor to be 3. So instead of 220, this was 240. Right here. Can I type? Maybe that'll be better. No, can't type. Okay. So 240, right? We have 1 times 240. We have 2 times 120. We have 3. That would be 80, right? We'd have 4, which would be 60. And with just those, we're well beyond 240. And then we also have 5, which would be something. 40, 58. 48. We'd have 6, which would be 40, etc. So the more lower numbers divide into it, the higher sum of the divisors you're going to have. Just because these are bigger numbers. Interesting. First 10 amicable pairs. And this is a pretty niche definition as well, just like the sociable numbers were. So, of course, there's big gaps in between them, right? Yeah. And, like, at the point you reach, like, these, you're probably not doing it by hand, right? You're not going number by number, just writing it out. There should be decent should be decently easy to like make a computer program that figures this out for you. I took one Java class in college, and I feel like this wouldn't have been hard for me to figure out to make a simple little program that at least solved for whether or not a certain number was an amicable pair, if not just running down a big list. Oh, a pair of amicable numbers constitute an aliquot sequence. So let's reread what an aliquot sequence is. Sequence of positive integers in which each term is the sum of the proper divisors of the previous term. So these all have sequence 2. There's 2 numbers. Sequence of positive integers in which each term is some proper divisors of the previous term. Okay. Okay. So if I pull up sociable numbers again. Is that? Nope. Sociable numbers again. Sociable numbers are numbers whose aliquot sums form a periodic sequence. Um, no, maybe I don't understand. Finally clicked what an aliquot sequence, or yeah, aliquot sequence was. Sociable numbers are a lot. All right. So an aliquot sequence, for example, an example of an aliquot sequence is 220 and 284, with a period of 2, meaning the length of 2, right? It's 2. So an aliquot sequence is a sequence of numbers where each number, so you have 220 and 284. So this only has a sequence 2, so it's not a super great example, but 220 to 284. So 284 is the sum of all the divisors of 220. That's what makes this a sequence. It's also what makes them an amicable number. But amicable numbers decide, or say these two numbers are amicable, right? An aliquot sequence, I think, let me reread real quick. No, I'm not fully understanding this. The aliquot sequence starting with a positive integer k can be defined formally in terms of the sum of divisors. The aliquot sum of a positive integer is the sum of all proper divisors of n other than itself. The aliquot sequence of 10 is 10, 8, 7, 1. Okay. Okay. So let me snip this here. Share it. We're learning math. Love it. Yeah, okay. Aliquot sequence. So we start with a number and the aliquot sequence for that number is, so let's take, we're going to do a different example. This is 10, right? So let's take 12. 12's divisors are 1, 2, 3, 4, and 6, right? All those can divide into 12 evenly. So the first number here would be adding all these together. So 10, 13, 15, 16. So we have 16, right? And then the divisors of 16 are 1, 2, 4, 8, right? So add all those together, that's 15. Divisors of those, 1, 3, 5. So we have 9. Then we have 1, 3, which is 4. Then we have 1, 2, which is 3. And then we have 1, which brings us down to 1. So that would be the sequence, right? I think. Let's see, aliquot sequence of 12. Just doing quick Google to make sure that I did this right. So yeah. 16, 15, 9, 4. Yeah. Okay. It's kind of neat, right? Then if I look at, we look back to sociable numbers, can we make sense of this? Sociable number. Sociable number whose aliquot sums form periodic sequence. Okay, periodic sequence. Mathematics of periodic sequence. Okay. So I think then what this is actually saying is yeah. Yeah. So let me snip this example again. Okay. Okay. Yeah. Uh, now that I know it, I know better what I'm looking at here. Oh. Here's the example of the sociable number. Right. So here's the sociable number, 1 million, blah, 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 blah. As a sequence of period 4. So we take the sum of all the proper divisors, just like we just did with 12, right? All these divide equally into 1 million, blah, 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 blah. That equals this, so we take the sum of the proper divisors of all those, bam, get that number, take the sum of all the proper divisors, take the sum of all the proper divisors, and then we get back to this. Right? Which is where in the sociable numbers we see let me find the right page here. Sociable number, the aliquot sums form periodic sequence. So if you keep finding the aliquot sums, a periodic sequence is where the numbers are repeated over and over and over and over. If you just keep finding the aliquot sequences or aliquot sums, adding all the divisors together, you'll have the same 4 strings of 4 numbers time after time after time. So that's what a sociable number is. If you add all the divisors together, you get a number, add all the divisors, add all the divisors, add all the divisors, you'll eventually find it equals the same as your starting number. Right? And then it repeats. So sociable number is kind of an extended version of the amicable numbers. So we should have started with amicable numbers. Amicable numbers are 2 numbers whose divisors equal each other. Okay, cool, fine. Sociable numbers are numbers where a single number, by finding the aliquot sums, will eventually yield itself again. You'll have a sequence and a period equal to however many. That makes sense? Makes sense to me now. Don't ask me to go find a new sociable number or anything, or new amicable numbers. But cool. That leads us to betrothed numbers. The last of the numbers. Betrothed numbers. So betrothed numbers are quasi-amicable. And amicable are the two where the divisors equal each other. Are two positive integers that the sum of the proper divisors of either number is one more than the value of the other number. Wow. So if I'm understanding this right, M and M are a pair of betrothed numbers if the sum of the divisors of M equals n plus 1. And the sum of the divisors of n equals m plus 1. Right? So let's take this first pair, for example. We have 40. Let's do this in this. 48, right? What are the divisors? We have 1, 2, 3. It's 24. I'll just do what they multiply by here alongside. 16. 4 goes into 12. 5, no. 6. Yeah, 6 times 8, right? 6 times 8. And no to 7, so that's all of them, right? Once you start multiplying by higher numbers than these, then one of the divisors, you start doing extra work. Anyway, those are all the divisors. So we add them all together. 6, 10, 16, 40, 56, 68, 76, which is one more than 75, right? So let's do all the divisors of 75. We have 1, no 2, 3 times 25. Not 4, 5 times 15. And I think that's all. Because it's not 7, not 8, not 9, 10, no 11, no 12, 13. No, because it'd have to be 13 times 14. Okay, so that's all of them. So 8, 9, plus 40, 49. All right, cool. So betrothed numbers are where pair of two numbers where the sum of the divisors of one equal the other one plus 1, right? 75 plus 1 is 76, which is equivalent to the sum of the divisors of 48. 48 plus 1 is 49, which is the sum of the divisors of 75. Betrothed numbers. Interesting. These seem... Okay, sure. All known pairs of betrothed numbers have opposite parity? What's that mean? I don't know. I don't know. Anyway, neat. So, that is um the maybe short 40 minutes, long or short version of sociable numbers, amicable numbers, and betrothed numbers. I'm not a teacher, but if you're interested in math and were able to follow along, great. If not, I don't know. Oh no, that's deleting another thing. Okay. Well, um, yeah, Wikipedia is a good source of information, particularly for math, that I found. Even as I was going through college and needed help understanding certain concepts, certain kinds of numbers, right? Um, it was really helpful. And if there ever wasn't enough information, I could search in one of the sources down at the bottom of the page. Um, Always good to double check your sources. Um, and of course, give credit where credit is due. Um, in this case, I didn't check any of my sources, but it'd be weird to have incorrect information on mathematical stuff. Anyway, hope you enjoyed, and yeah, that's it for me. If I find more questions that pique my interest in Persona 4, I will make another video about them. In addition, if you want to see, I suppose, more things involving math, I like math. I have a degree in it. Probably more than happy to make a video about other concepts, even if I have to work on learning them. Yeah. Alright, thanks for watching. Peace.